Hello, this is our assignment 1 of Pervasive Networks CE4021. My team members are Yubo, Qihuang, and Yuen Kai Him. Today, we'll talk about a paper from IEEE Wireless Communication Magazine regarding Full Dimension MIMO, also known as FD-MIMO, the next evolution of MIMO in LTE systems. It is published on June 2014, Volume 21, Issue 3, page 92 to 100. Let's start off with a little bit of background information. Back in 1990s, data networks started with GSM. Now 2014, we are using LTE. Mobile communication has advanced through the years from 1G at 2.4 kilobits per second to 4G, clocking a spectacular 1 gigabit per second, which is almost a million times more. But as time goes by, there are also more and more users, therefore requiring an increase in demand for data speed. As silicon technology improves, the processing power of user equipment increased exponentially as well. With that processing power, it made higher resolution image, audio, and video processing possible. But it also means that the size of the multimedia files are going to be increased simultaneously. Another main reason are smartphones and tablets applications becoming more and more complex. From the original voice and text to internet surfing, picture and video sharing, video conferencing, and lastly online gaming. All these applications crave for higher data bandwidth. Mobile internet has also become cheaper. More and more people have access to the internet globally, and some may even have more than one device connecting to the internet at the same time. However, people are still irritated by this, therefore arising a need to have faster mobile network. FD-MIMO is the new candidate technology for the next generation systems. With Samsung in the lead, you can't imagine the significant attention it has garnered in the wireless industry. With the FD-MIMO technology, as quoted from Samsung head of DMC Research and Development Center, 5G cellular systems is just around the corner. Now, let's talk about the concept of FD-MIMO and how does it work. FD-MIMO utilizes a large number of antennas in a 2D array panel to realize high-order multi-user MIMO transmission known as MU-MIMO. MU-MIMO uses large number of antennas at the base station to transmit and receive spatially multiplex signals to and from large number of terminals. Comparing to the conventional LTE systems of MIMO transmission, FD-MIMO has two important differentiating factors. Firstly, the number of antennas has been increased beyond what is supported in the conventional LTE systems. As a result, beamforming and spatial user multiplexing capabilities significantly improved. Secondly, antennas are no longer placed in a 1D linear array but in a 2D planar array. The main motivation of this planar placement is to reduce form factor of the antennas. Having 64 antennas in a 2D planar array will require a form factor of 50 by 50 centimeters, but it will be 4 meters wide if the antennas are still placed in a linear array. Enhanced feature of FD-MIMO allows the deployment in all of the 4 scenarios. Most users in urban locations are indoors on different floors. Having the capability to control the beam direction in the elevation and azimuth domain enhances the system performance. The scenario of high importance is the high population density, such as stadium, malls, and airports. In such scenario, FD-MIMO is able to allow thousands of users to simultaneously access the system while still having high quality services. The performance of the FD-MIMO is just magnificent. It increases the user capacity by 10 times and still manage to achieve a higher throughput. According to the 3GPP's roadmap, FD-MIMO technology will be released in the very near future. By then, our smartphone will be able to achieve an even higher data transmission rate. Thank you for watching.